Number 7 is asking for the integral of the product of x minus 1 and the square root of x. So the first thing to think about here is that this problem is going to be a lot easier if we rewrite that expression as sort of like a polynomial. And to do that, we want to reinterpret root x as a rational exponent of x, so x to the 1/2. And so the first thing I'm going to do is I'm going to rewrite this problem as the integral of x minus 1 times x to the 1/2. That way we can use our exponent properties to correctly distribute the x to the 1/2 to both of these terms. So we'll use the distributive property to simplify this. X times x to the 1/2 is going to be x to the 3/2. And that's because whenever you multiply two powers that have the same base, you will add those exponents. So 1 plus 1/2 would be 1.5 or 3/2. X to the 1/2 times -1 would just be negative x to the 1/2. So now that we've written this in sort of a pseudo-polynomial form, we can then just use the anti-power rule. It goes a little something like this. The integral of anything in the form a times x to the n dx will be a over n plus 1. Basically, you increase the exponent by 1, divide the coefficient by that new exponent. So we'll have x to the n plus 1, and then also divide that coefficient by whatever that new exponent is. And then, of course, plus c. So we'll take this one term at a time and find the antiderivative of that expression. So this is going to equal, let's see here, if I need to increase the exponent by 1, I need to add 2 over 2, so that'll be 5/2. Now, the original coefficient here was 1, so you could think about this as like 1 divided by 5/2. But anytime you divide 1 by a fraction, all that really does is just gives you the reciprocal back. So 1 divided by 5/2 is the same thing as 2/5. Minus, if I add 1 to 1/2, I get 3/2. And then I need to divide by 1 by 3/2, which is the same thing as multiplying by 2/3. Of course, I need that plus c anytime you find an indefinite integral. And so there you go. Our answer is A.